Hello everyone, I am Karan Mashru. Welcome to this video. In this video, we are going to discuss solution of the problem of the day, that is solve the Sudoku. First of all, let us start by understanding the question. What does question say? It says that given an incomplete Sudoku configuration in terms of a 9 cross 9 2D square matrix named grid, the task is to find a solved Sudoku. For simplicity, you may assume that there will be only one unique solution. So basically what it's saying is that something this kind of 2D matrix we are given, which is of size 9 cross 9, and the name given to this is grid. Okay, and this represents an incomplete Sudoku configurations, means some of the places will be filled with numbers and some of them will be empty. We need to find the solved Sudoku. It means that following the rules of the Sudoku, we need to fill the complete table and fill the places with appropriate numbers. Okay, and if if the solution exists, there will be only a unique solution. Okay, now let's read further. What does it say? A Sudoku solution must satisfy all of the following rules. First, each of the digits 1 to 9 must occur exactly once in each row. Each of the digits 1 to 9 must occur exactly once in each column. And each of the digits 1 to 9 must occur exactly once in each of the 9 3 cross 3 sub boxes of the grid. What does it say? It says basically that in each of these rows, we want all the numbers from 1 to 9 present. In each of these columns, we want all the numbers from 1 to 9 present, right? We need this for row as well, and for each column also we need all the numbers from 1 to 9 present in each of the column. And the squares 3 cross 3 size sub matrices, which I have represented with the help of yellow border, in each of these sub matrices, which contains 9 cells, in each of these also I want all the digits from 1 to 9 present. So basically in each row 1 to 9 will occur exactly once, right? In each column 1 to 9 will occur exactly once, and in each of the boxes as well 1 to 9 will, all the digits from 1 to 9, that is 1 2 3 4 5 6 7 8 9, all will occur exactly once, because the row in one row there are 9 columns, in one column there are 9 cells, and in one sub matrix of size 3 cross 3 also there are 9 cells. So all the numbers from 1 to 9 should occur exactly once in each row, each column, and each sub matrix. Okay, now let's read further. Zeros in the grid indicate blanks which are to be filled with some number between 1 to 9. You cannot replace the element in the cell which is not blank. So basically in the input we are given an incomplete configuration of Sudoku. So some of them, the places will be blank, like in this case these places will be represented using 0 in the input, and the places which are not blank will be represented using the given digits. We can only fill the places which are represented with 0, means which are empty initially. We should not replace any of the digits which are given beforehand. Okay, if we look at the example, the grid matrix we are given here in this format, the zeros represents the blank spaces which we need to fill. We do not need to touch these digits, we do not have to move them or replace them. So for this input, the output is true. It means that for this incomplete configuration there exists a unique solution, so it is true, and this is printed. Okay, so explanation is there exists a valid Sudoku. Okay, for example 2, this is the input grid, output is false, and since it is false there is no solution present for that matrix or for that grid, so we do not print anything further. There does not exist a valid Sudoku for the input grid. Okay, now the task we need to do is we need to complete two functions. First is solve Sudoku, which takes the grid, that is the incomplete Sudoku configuration 2D matrix, as its argument and returns true if a solution is possible and false if it is not. So basically in that function we will write a code such that it checks whether this incomplete configuration can be completed to a solved Sudoku or not. Okay, does it satisfy the three properties which were mentioned? Can it satisfy? If yes, we will return true, otherwise false. The second function we need to complete is print grid functions, which takes grid as its argument and prints the 81 numbers of the solved Sudoku in a single line with space separation. So what it basically does is, it takes the grid as the input and prints all the 81 numbers. There are 81 numbers. It's a 9 cross 9 Sudoku, right? So total cells would be 81. So it takes the grid as the input and prints all the 81 numbers in a single line, and they are separated by spaces. Okay, we do not have to print new line anywhere. We just have to print them in a single line. Do not give a new line character after printing the grid. It has already been taken care of in the driver code. The expected time complexity is 9 की power n cross n. N is basically nothing but 9. Okay, that is the size of this 2D matrix. So 9 cross 9, and the expected auxiliary space is nothing but big O of n square n, that is nothing but 81. Okay, here n is fixed. We are given a 9 size Sudoku, and the value of the grid is between 0 to 9. Wherever there is 0, it is a blank space, otherwise it's a pre-filled value. Okay, so now if we think about the concept of how we will solve this problem, so basically we have been given an incomplete Sudoku configuration and we need to find a solved Sudoku if possible. Now understand one thing, what we need to satisfy, the solved Sudoku should satisfy that each row will have all the digits from 1 to 9 exactly once, each column will have all the digits from 1 to 9 exactly once, and each of the submatrix of size 3 cross 3 will have all the digits from 1 to 9 exactly once. Now here the expected time complexity given to us is 9 की power n cross n, where n is nothing but the rows, number of rows and number of columns, which is nothing but 9. Now if I try solving this question using brute force, it means that I will generate all the possible configurations of this incomplete Sudoku, placing each and every possible number, and for all the configuration which I get finally after filling in the Sudoku, I will check whether they satisfy the three conditions for a solved Sudoku. If they satisfy, if any one of them satisfy, I return true, otherwise I'll return false, right? So what would be the time complexity for that? See, here each position can have, in brute force method, if we try to generate all the configurations, each position can have 9 digits, 1 2 3 4 5 6 7 8 9, right? And suppose I have to fill n cross n places, right? Of course some of them will be filled beforehand, but suppose I have to fill all the places, then how many different configurations will I get? See, I'll get, there are 9 possible digits to be, which can be filled in one cell, right? And there are n cross n cells, so the total number of different configurations would be 9 cross 9 cross 9 cross up till n square n times, because each cell can have 9 values, so the overall total number of configurations will be this much. See, it's like similar which we do in permutation and combination. Suppose there are 3 places to be filled with the help of the digits 1 2 and 3, then how many total different numbers which we can generate? Here there are 3 possibilities, either 1 or 2 or 3. Here there are 3 possibilities, and here there are 3 possibilities, so total we can generate 27 different numbers. Similarly, each cell have 9 possibilities and total number of cells is n cross n. So the total number of different configurations will be 9 की power n cross n, which is the expected time complexity. So what I can do, I can try and generate all the possible configurations and check after a configuration is completed, each time we will check whether it is a solved Sudoku, if whether it satisfies the condition of a solved Sudoku or not, right? So what we can do is basically, see, we have to complete the function solve Sudoku, right? So in this function what I can do is, first of all, I do not have to replace the numbers which were already there. I have to only fill the places which were represented using zeros. So I can take a 2D array named empty, which will be of size 9 cross 9, right? And if a particular cell is already filled, I'll say empty of that cell is 0, which means it is not empty, we do not have to fill it, and I'll mark it as 1 if it has 0, which means we have to fill it. Other than that, what I can do, I can take row of 9 cross 10 size. What will this indicate? Row of ij will denote me the count of number j in the ith row. I need to check for each row, each column, and each sub square matrix whether all the digits from 1 to 9 are present exactly once. So how will I do that? I'll do that for each row. I'll do that with the help of this 2D matrix. Row of ij will denote the count of number j in ith row. Similarly, I'll take one column of 9 cross 10, which will denote what? Nothing but a column of ij will denote the count of number j in the ith column, right? And I'll take square of 9 cross 10, which will denote nothing but square of ij will denote nothing but the count of digit j in the ith square. If I denote here, this will be the 0th square, this will be the first square, this will be the second square, this will be the third square, this will be the 4 number square, this is the 5th number square, this will be the 6th number square, this will be the 7th number square, and this will be the 8th number square. Okay, the sub square. Okay, so I have taken this. Then what I'll do is I'll take one global variable called solved, which will be initialized with 0. If I find a solution, I'll mark it as 1, and I'll call fill grid function. So this was in this function solve Sudoku, which we have to do. I'll do these many things, and I'll call fill grid function, which will basically fill the Sudoku. Okay, now what will happen is in the fill grid function, what I'll do is I'll recursively try and generate all the possible configurations. So basically what I'll do is, suppose if I suppose this is a small sub matrix, okay, and here there are zeros. So I'll start from here and I'll put 1 year, then I'll put 1 year, then I'll put 1 year, and so on. Then I'll backtrack and put different configurations. Recursively, what I'll do is in one place where there is 0, I'll try 1 and then fill in the further empty places. Then I'll fill the further empty places. Once all the empty places I filled, then I'll check whether that grid is valid Sudoku or not. Then I'll again backtrack and change the configuration, and in this way I'll try all the different combinations of the possible solved Sudoku, right? So basically what I can do here is, initially in the fill grid function, I'll pass the indexes 0 and 0. I'll start filling it from here, then I'll move rightwards till here, then I'll come back here. In this way I'll keep filling the rows until I fill this one. As soon as I reach here, I understand that I have made one configuration, right? So now what I need to do is I need to check whether that grid is solved Sudoku or not. Okay, don't worry if you are not getting it a little bit. As we will move further and see the implementation code, everything will be clear. Okay, so now basically I have called fill grid function. So when I'll call it for the first time, I'll call it with the help of 0 0, then I'll go to 0 1, then I'll go to 0 2, and so on up to 0 8. As soon as my column number becomes 8, what I'll do is I'll increase the row number and I'll make the column number as 0. So basically fill grid 0 0, then I'll go to 0 1, then I'll go to 0 2, up to I'll go to 0 8. Now I have reached the 8th column, so I have to change the row. So what I'll do is, now I'll go to first row and 0th column. In this way finally I'll reach the 8th row and 0th column, then 8th row, first column, and then up till 8th row and 8th column. After this I'll reach 9th row and 0th column, but there is no 9th row index wise. There are total 9 rows indexed from 0 to 8. Since there is no 9th row, what I'll do is I'll from here, I know that if I have called this fill grid with the 9th row and 0th column, it means that all these cells are filled with some numbers, right? So when I'll reach here, what I'll do is I'll call check grid function. Now what will check grid function do? the check grid function, it will basically check whether for all the values of row ij is it equal to 1. Row ij denotes the number of occurrences of jth number in ith row. So is all the row ij values equal to 1? It should be equal to 1 because all the numbers from 1 to 9 should be exactly ones in all the rows. Then it will check for columns whether all these values are ones. Then it will check for squares whether all the values are 1. Square of ij denotes the number of occurrences of j in subsquare I. So whether all of them are equal to 1. Out of these, if any one of them also is not equal to 1, it means we have not got the solved Sudoku. So after checking that, if any one condition is also not satisfied, what I'll do is I return back to fill grid, and I'll again backtrack and fill with another combination or another configuration. But in case there are no errors and I have got a solved Sudoku, I'll mark the solved variable as 1, which is my global variable, solved equal to 0, which I had initialized. And once I mark it as 1, while filling the grid also, I'll take care that if the solved variable is 1, then I do not have to try further combinations. I'll return back this to solve Sudoku with true, that okay, we have got a solution. But in case after trying all the different combinations, even then we have got solved equal to 0, we will return what? We will return false. And the print function is very easy. Now one of the things which you might have doubt is, okay, this is the 0th subsquare, this is the first subsquare, this is the second subsquare, but how will we calculate that, right? Calculating row number and column number is very easy. So now I hope you have understood the concept. What we are trying to do, we are trying to recursively generate all the different combinations by filling each and every possible number at a particular cell which is marked with 0. And after we get a one configuration filled completely, we will call the check grid function, which will check whether this is a valid Sudoku solved or not. If yes, we will mark the solved variable as 1 and return, and this will again return back to here. If not, we will try the another configuration with the help of recursion and backtracking and further check that grid and so on and so forth. Now let's look at its implementation code, which will make things very clear. So if we look at the implementation code, this is the first solve Sudoku function. So what I have done here is, as I said, I have taken an empty 2D array which will denote whether that cell is empty and is to be filled by us or not. There is the row 2D matrix, there is the column 2D matrix, and there is the square 2D matrix, and some other variables which we will use. Then what I have done is, initially I have marked all of them with 0. Then if grid of ij equals to 0, it means it is an empty cell. Then what I'll do is I'll mark empty ij equals to 1. It means that it is empty and it is to be filled by us. Because what will happen during recursion and backtracking, if we do not know which cell was initially filled and which we have to fill, then we might replace values of the initial cells also, which we are not allowed to do. Okay, if that is not equal to 0, it means it already has a value. Then first of all, see, suppose it is row number I and the value is 8, then I have to do row I and value 8 plus plus, because this denotes the count of 8 in the ith row. So that is basically what I am doing here. Row I and the value is grid ij plus plus. Similarly for column and similarly for square. Now for calculating the square value, whether it is 0, 1, 2, 3, 4, 5 or 6, 7, 8, the square value which I showed you before, I have made a function which gives input as the row number and the column number and returns the square number, which we will see further. You will get a clear idea. And the value is grid ij plus plus, and I'll also mark it as empty ij equals to 0 because it is not empty, it was pre-filled, we do not have to fill it. Then I also have a global variable solved which is equal to 0, okay, initially. Then I'll call the fill grid function, which will fill the grid recursively and try all the different combinations. Now let's see that. So this is the fill grid function. So first of all, do not look here, let's understand this part. So first of all, if empty ij equals to 1, it means it is empty and is to be filled by us. Else it means it is not empty and it is pre-filled. Okay, if it is empty, then from k equals to 1 to 9, I have to fill all the values possible in that cell, because I have to generate all the possible combinations. So what I'll do is I'll take k equals to 1 to 9 and fill it in that cell one by one. But I'll also check that at any point of time my solved variable is 0. Only then I'll keep looking for new configurations. If it is 1, it means we have got a solution. We will just return to the main function, right? So if row of ik equals to 1 or column of jk equals to 1 or square, calculate square number, that is calculate grid ijk equals to 1, then continue. What does that mean? This is just a small optimization over the absolute brute force. So suppose in the ith row k has already occurred once, so that is what this is representing, count of k in the ith row, or it has already been come once in the jth column, or it has already occurred once in the square grid which is represented in the ith row and the jth column, then I cannot fill it again. So I'll just continue to the next k value. If not, then I'll mark the grid value with k. I'll increase its count. I'll increase its count in the column, and I'll also increase its count in the square. Okay. If j equals to 8, see, as I said, in one row there are 8 columns, sorry, 9 columns. So I'll keep moving like this and fill all the different combinations. But as soon as I reach 0, 1, 2 up to 8th column, then I'll move to new row. So that is what I'm doing. If this I and j which comes inside the function are nothing but row number and column number of the cell which we have to fill. If j equals to 8, then fill grid function, I'll call it recursively, and I'll go to new row I plus 1 with column number 0. If it is not equal to 8, it means it is not the last column in that row. I'll just go to the next column in the same row. So I'll call the same row number, but column number will increase by 1. After that, I'll replace, so after this function fill grid, so this is something our, let's say this is some part of our grid. So suppose I filled here 7, then it recursively went here, then it will recursively go further in all the cells. When it will come back, now I want to try here 8, right? I tried 7, now I want to try 8 and generate all the different combinations. So before that, I'll have to subtract that count from the particular row which I added here. So I'll subtract that count from the row, from column, and from the square, and then continue with the next k value, right? And this will recursively generate all the different combinations. And if it is not empty, so if it is pre-filled, then what we will do, we will simply go to the next cell. So if it is last column, we will go to new row and 0th column. If it is not last column, we will stay in the same row, but column number will increase by 1. So this is when we want to fill it. Now after filling all the cells, where we will reach, the last cell to be filled by us will be 8, 8. After that we will reach to 9, 0 recursively. So if I equals to 9, it means that the row number index is 9. So it is 10th row which we do not have to fill. So what we will do, we will call the check grid function and ask it to check whether the given grid is valid or not. Is it a valid solved Sudoku? If it is true, we will mark solved as 1 and we will return from here. Okay. So return we will do it anyway. Even if this is true or false, we will have to return from here because this is the row number 9. So we do not have to fill it, right? Now let's check the check grid function. So if we talk about the check grid function, so basically what it is doing, that first of all it is assuming that answer is equal to true, which means that it is representing a right Sudoku, solved Sudoku, okay, correct configuration. Then we will check for each of the conditions. What was the condition? In each row all the numbers from 1 to 9 should occur exactly once. So row ij should be equal to 1 for all the ij. So I'll go from I equal to 0 to 9 and j equals to 1 to 9. Why? Because this is the row number. It starts from 0 and it goes till index 8. This is the j is representing the value which is filled in that row. This is the index number and this is the value which is filled. So this will start from 1 to 9. Okay. if row ij is not equal to 1, if the counting of j, if the occurrences of j in the ith row is not 1, either it is less or more, we will immediately say answer equal to false and we will break from here. Here also you can add a statement, if answer is equal to false, no need to check further, just break. Okay, so you will come out of this for loop also. Again same thing for the, for each of the columns we are checking. Okay, you can also add this if statement here also, and the same thing we are doing here for each of the squares, whether each subsquare has the count of j equals to 1 or not. If any one of them do not have, we will make answer equals to false and break. Also one thing, since j represents the value, here while calling the calculate grid which calculates the subsquare using the row number and column number, we will pass j minus 1, because row number and column number starts from 0 index, and ultimately we will return the answer variable which is either true or false. Okay, now let's see the calculate grid function. So if we talk about the calculate grid function, what it basically does is that it calculates the subsquare, which number subsquare it is, based on row number and column number. So if we just move on here, for the first, for the 0th number subsquare, the row number goes from 0 to 2, sorry, this is the column number goes from 0 to 2 and the row number also goes from 0 to 2. For the second, row number goes from 0 to 2, column number goes from 3 to 5, and for the third subsquare it goes from 6 to 8, the column number, the row number remains 0 to 2 only. Similarly here the row number in this case moves from 3 to 5, and here it moves from 6 to 8, and the column numbers respectively are 0 to 2, 3 to 5, 6 to 8, and so on. Based on that we can assign the grid number. So that is what I have done here. If I, that is the row number, is less than equal to 2 and j is less than equal to 2, it is 0th grid number. Okay, it is this one. Then if the row number is less than equal to 2 and column number is less than equal to 5, it is the first grid. Okay, similarly if the row number is less than equal to 2, column number is less than equal to 8, it is second, then third, then fourth, then fifth, sixth, seventh, and eighth square matrix, depending upon the row number and the column number. Also we also have to finish this print grid function, which said to print all the 81 numbers of the grid in a single line using spaces. So that is what I have done here. I have simply printed them using spaces. Now let's look at a small thing in the solve Sudoku function as well. So after finding all the different combinations, if in case in between we have got the solved variable as 1, we have got a correct solved Sudoku, we will return back. Otherwise, after trying all the different combinations, finally we will return back to the solved Sudoku function, from where we call the fill grid function. So if our global variable solved is 1, it means we have found a solved Sudoku, we will return true, otherwise we will return false, right? Now let's submit this code. So let's submit the code. So we have solved this successfully. And if we discuss about the time and space complexity, so what would be the time complexity? It would be approximately big O of 9 cross 9, because we are trying to generate all the different combinations. Also we have used some optimization here. If you remember, while filling a value, we checked whether that row contained that value already, or whether that column contained that value already, or whether that subsquare contained that value already, right? So it will be a bit less than that, but approximately it would be 9 to the power n cross n. And it may happen that if you do not apply that small optimization, your code may give time limit exceeded. Okay, and if we talk about the auxiliary space, what would be the auxiliary space? The auxiliary space, here what we have taken extra, we have taken an empty array of size 9 cross 9, right, to denote whether a cell was previously filled or not. Similarly, we have taken a 2D array row, we have taken a 2D array column, and we have taken a 2D array square. All of them were 9 cross 9 size. So I can say auxiliary space is nothing but big O of n cross n, where n is the dimension of the matrix which we are given. I hope you have understood this question completely. Thank you.